All right, so this is an application to find the position function based on an acceleration, an initial velocity, and initial position. So our ball is being thrown directly upward on the moon with an initial speed of 24 feet per second from a height of 100 feet above the ground, and the acceleration due to gravity is 6 feet per second squared. So let's take a look at what's happening here. So if I hit play, this is what happens. Our object goes up, our ball, and then comes back down and hits the ground. So you can see that we have an initial height of 100 and that our initial velocity is 24, launching it up. That'll give us a max height and everything else we need. So if you notice though, our acceleration is it slows down immediately and then goes straight down. That means our acceleration is negative. So our acceleration with respect to gravity is negative, and that's feet per second, so second squared. Our initial velocity is 24 feet per second. So by plugging in 0, that gives us our initial velocity and height. So you can see it here if I move it back. Right there, my time is 0. Time 0 means height is the initial velocity of 100. So S sub 0 would become 100 feet. So now that we have the initial height, initial velocity, and acceleration, we can find what we need. So we want to find the expressions for the velocity and height of the ball. So we need the velocity and position functions. So if you remember, by taking the integral of our acceleration with respect to time, it's going to give us our velocity. The antiderivative acceleration is velocity. So this would be negative 6t plus c. And then we also know that our initial velocity, so if I plug in 0, I'm going to get 24. This means that c is equal to 24. So plugging these together, we get negative 6t plus 24. And then we stop and check. So if I plug in 0, I get 24, perfect. I take the derivative of this, I get negative 6. Now position. If we take the integral of the velocity, it will give us our position. So remember, antiderivative velocity is position. So this is negative 3t squared plus 24t, and then we put plus d. And then we know our initial position at 0 is 100. So plugging that in, we get 0, 0, and d. So d is 100. So that means our S of t is negative 3t squared plus 24t plus 100. And again, we stop and check. So by plugging in 0, I get 100. Check. Taking the derivative, I would get negative 6t plus 24. So everything checks well. Now we have our position, our acceleration, and our velocity function. We can answer any question they want to throw at us. So it says here, at what time does the ball reach its highest point? So that means we are maximizing height. So that means we need to find S prime of t, which we already know is v of t. So if you take the derivative, you get negative 6t plus 24. And remember, to find the relative max and mins, we want to set that equal to 0. So negative 6t equals negative 24. So t equals 4 seconds. So at what time will we reach our max height? 4 seconds. Let's check. So I've plugged in 4 seconds, and yep, going to the right we go down, going to the left we go down. So that is our max height right at 4 seconds. And what is our max height at 4 seconds? 148 feet. But remember, these are critical points that we're looking for. So what we still need to do is plug 4 in to find out what the height was at 4. So negative 3 times 4 squared plus 24 times 4 plus 100 gives us 148 feet. Now remember, you also want to check these in your calculator or with Desmos. So you remember, our position function is just that parabola. So right there, that is our max. So at 4 seconds, we go to 148 feet. So remember, all this is doing is matching the height to the parabola as it goes up and then back down. So when we take the derivative, it tells us our maximum, max height, and at what time that was to reach that max height. All right, what about this one then? When does the ball strike the ground at the base of the cliff? So when it strikes the ground, that means its position is 0. So when you look at our projectile, get rid of the parabola. It goes up, comes back down, and then hits the ground. So what is that height? It's 0, right? So we're trying to find when does our position function equal 0. So if we take our position function, and factor it or use quadratic formula, it'll tell us when it hits the ground. So using quadratic formula, we get 11.02377 seconds. But you can also just use Desmos or a graphing calculator to find out when the parabola creates your 0 for the function. So 11.024 would be fine as well. But there is the exact answer for this as well. So when t equals 11.02377 seconds. So now the fun question is, what's the velocity at that time? So what is the velocity when it hits the ground? So if we take and plug it into our velocity function, so we plug in our 11.024 seconds into our velocity function, what do we get? We get approximately negative 42 feet per second. So that's how fast it will be traveling when it hits the ground. So we got everything from this little object. We now know that it's going to go up to a max height at 4 seconds. It will hit the ground at around 11, so it'll have 11 seconds of air time, and when it hits the ground, it's going to be doing 42 feet per second. All from just an initial velocity, an initial height, and an acceleration. I think that's pretty cool.